So if you've listened to it on the radio, you've watched it on television, those waves have to be broadcast across an antenna and probably manufactured, designed here in Indiana's Great Southwest at Electronics Research. That's where we're here today, and you're going to find out more. Company that started in 1943 for the military that has morphed into this amazing company that's global, Electronics Research, right here in Chandler, Indiana, Warwick County. Tom Silliman's with us today. Tom, tell us how everything started.
Well, during the World War II, there was a group of scientists called the Radio Research Labs at Harvard in Boston, and they were developing products to interfere with the Germans and the Japanese, who are then are now our allies, but at the time they were our enemies. And the German U-boats were in the harbor in Boston spying on them. And then one of the team was a guy named Caraway that lived in Newburgh, Indiana. And he pointed out that the Ohio draft was only 8 feet and the submarines couldn't come up. And the Germans hadn't developed the flying wing yet, so they couldn't bomb Evansville. So he suggested he come to here and develop a company at the airport in Evansville, and that the team in Harvard could fly engineers named my father here to do their research. And then after the war, my father went to the FCC to work and then later became a broadcast consultant, one of the top ones in the country. And then Caraway hired my father to help him develop antennas for radio, which was a new industry, very small industry at the time. And then later on, Mr. Caraway passed away, and my father bought half the company and had locals on the other half and had me to go to work for it when I was 16 in Maryland.
So it's kind of amazing. You come back from the war, all of a sudden you were seeing in vehicles, radios are appearing in cars. You needed to come into antennas. That was back in 1945, 1946. You fast forward to today, we've really seen some changes in the broadcast industry. I mean, what kind of changes have you seen over the period of time?
Well, originally the cars all had AM radios in the 50s, and they had a vertical antenna. And then FM radio was introduced in around 1960 or so, and it was all horizontal polarized. And in the mid-60s, the FCC authorized vertical polarization so that the cars could have FM radios in them and use the same antenna for the AM, which was vertical. And my father and I worked in Maryland in our basement designing a vertical antenna that could be used with horizontal antennas, which we still make today. It's the 300 dipole, and a dual cycloid, which was a circular polarized antenna that had vertical and horizontal, and then that product really took electronics research up to the next level. In the early 70s, the transmitters for FM, which is solely what we were an FM company, they were getting bigger and bigger. And then Gene Wicker, who was the president of Harris Broadcast Products in Quincy, came to us, and he wanted a new design in 1975. And he wanted a design that could take 25 kilowatts per bay. He wanted a robust design. He wanted an aux use, and he didn't want any more arcing with these high-power transmitters. And so my father said, okay, design it. So we did. And that antenna was completed in January as a prototype, photographed, cataloged, and shown in Chicago at the National Association of Broadcasters Convention. And the only thing I can say, because it was the first one I went to, was everybody would walk by and go, what the hell is that? But it was totally different. It was internally fed instead of externally strapped. It was tested for lightning. It was designed as something that They would actually dissipate arcing, and it is the worldwide industry standard today for FM side mount antennas.
One of the amazing things at ERI is the 65-foot anechoic chamber. This specially constructed test chamber is lined with cones made from material that absorbs radio frequency energy and creates a reflection-free chamber that allows the radiation pattern of a television antenna to be measured accurately. ERI uses this one-of-a-kind facility to design its custom-made high-power television antennas, providing the maximum signal over the desired coverage area while protecting other television stations from unwanted interference. This is the largest anechoic chamber in North America, dedicated exclusively for broadcast applications, and helps ERI develop antennas with performance accuracy. With Bill Harlan, Vice President of Marketing for ERI. Bill, this is a pretty amazing complex. It's much larger if you look at it from the roadway until you come in here. It's significantly larger. I mean, how big is this complex?
Well, the complex we have here is about 100 acres, and we've got over 250,000 square feet under roof and 7 buildings. And 5 miles away from here, we've got a 50-acre test range where we do all of our FM antenna pattern development for directional FM antennas and master FM antennas, like the one we've got installed on the top of the Empire State Building. Actually, there are 3 master antennas on top of the Empire State Building that were all built here by this company.
So how many people actually work here within the complex?
We have over 200 people here, and then we have some remote salespeople that are not located at this that are operating from home all over the country.
With Kenny Brown, Chief Operating Officer for Electronics Research, you operate all around the world in various industries. Tell us a little bit about the industries that you operate in.
Well, our main industry is the broadcast industry, obviously. But across broadcast, there's TV broadcast, FM broadcast, and there's a litany of different products that have to serve both of those industries. From the top mount TV high power antennas to side mount high power TV antennas to low power TV antennas, down through the FM antennas, high power, low power. We have an extensive filter line that feeds both types of antennas. We have a feed line system manufacturing that we do here as well. We have a full service group that installs all of this equipment. So we're very diverse across the entire industry, and there's not another company in the United States that can do everything we do.
And not just in North America, but around the world that you guys work. I mean, how did it start off? You started probably domestically, but how did you move across the world?
Well, it's tricky because different markets have different needs, so we had to pick and choose what markets fit what the United States does. That was our predominant market, which is more high power. So we ended up in a lot of the Asia Pacific region, all of South America, Mexico. They have similar standards to what we run with here in the United States. So we do some work down in Africa, across Europe. So we touch just about everywhere.
This is a pretty unusual building, and when you look at the building here, you're thinking, well, this is not a metal building, but specifically, this is a wood building for a very specific purpose. And tell us about the building and what you do in the building here.
Well, the tuning techs behind us, they're going through and actually moving some devices that they're going to check here in a little bit to check to see if the antenna's in tune or within spec. Well, what they're actually doing is emitting a signal, and with any metal within this building could actually reflect that signal back to the antenna and give them false readings. So we use the metal and fiberglass structures to minimize or completely eliminate that bounce back, so we have good clean measurements when we're done.
So you're tuning this antenna prior to putting it in the field for use?
Oh yes, this antenna will be tuned to its exact frequency, and when it goes to site, they basically just stick it on the tower and plug it in and it plays.
So you just mentioned you have technicians that are doing this. Obviously, you have folks who are working in assembly, welding to put these materials together. What kind of skill sets, the kinds of folks that you have here, what's needed here at ERI?
Well, it starts with sales. So we have several salespeople across all of our product lines. We have product line managers down to, then it goes into our engineers. We have a very diverse group of engineers. And we're always looking for draftsmen. We use machinists. We have having technical people that we can get our hands on to bring them in here and train them in our part of the industry, because like no other industry you'll work in.
So I don't want you to divulge any secrets or anything, but what's the future look like for the industry?
It's interesting because we see a lot of collaboration between the broadcasters and the wireless industries. There's experiments going on right now in 2 different markets for SFNs, which are single frequency networks. It takes a collaboration between broadcasters of bringing content, being able to deliver it over long distances, especially on mobile devices. That's why we see a lot of our antennas going to what we call C or EPO, which are vertical and horizontally polarized, so you can receive that signal while you're moving, just like in a car or on a tablet. But what the broadcasters need is a way to get communications back to the broadcast station. They use the wireless infrastructure to do that and broadcast from a central location.
So just out of curiosity, now you have self-supporting structures, guy wire structures, but you also put antennas on top of buildings. What's the highest height that you've worked on?
Well, we put up a couple of different 2,000-foot tall towers with candelabras. So there's 3 candelabra arms sticking off the side. Matter of fact, if you ever drive down to Nashville, Tennessee, you'll drive right past one of our towers right off the highway. Buildings-wise, I know Tom has done a lot of work on Empire State Building, so we've got structure, we've got antennas on top of that building, and across just about every major building in the country we have equipment on.
Amazing. Right here in Southwest Indiana.